Ever had a system fail at the absolute worst moments? Well, in this explainer, we're cracking open the modern engineering playbook for taming that chaos and turning failure into a predictable, even manageable, part of the process. Just picture it. It's the middle of a huge sales event. Your website is flooded with customers, and then nothing. The site just freezes. The checkout button is completely dead. Yeah, the panic is real. Or maybe you're looking at a high-tech factory floor, the heart of your entire operation, and it just grinds to a dead stop. And every single second that ticks by is just money, literally vanishing into thin air. So what happens next, right? Is it total chaos, or is this actually part of the plan? Those next few moments are what separate the good engineering teams from the great ones. Today, we're going to pull back the curtain on the playbook that turns a crisis into a calculated move. Okay, so it all starts with a really basic question. What does working even mean? I mean, you can't hit a target you can't see, right? So the very first step is to turn those vague promises like high uptime into hard mathematical goals. All right, this is a super important distinction to get right. Think of the SLA, the service level agreement, as the promise you make to your customer. It's the bottom line. You break it, you could be paying penalties. But the SLO, the service level objective, that's your internal goal. You always set it a little bit higher, a little tighter, to give yourself that crucial safety buffer. Okay, we've got our target. So how do we actually know if we're hitting it? This is where all those acronyms come in. But don't worry, they're basically the shared language that keeps everyone on the same page about reliability. First up is the SLI, the Service Level Indicator. Honestly, the easiest way to think about this is as your live scoreboard. It's just the raw data, the hard evidence. No opinions, just facts. A simple formula, good events divided by total events, that tells you, right now, if you're meeting your goal. Now, whenever something does go wrong, it's not just one big event. It's a whole life cycle, a timeline. The second something breaks, a clock starts ticking. You've got the mean time to detect, how long till you even know there's a problem, then mean time to acknowledge, how long till someone actually starts working on it, then to repair. Each step is a metric you can track, and, more importantly, improve. Okay, this is one that trips people up all the time. MTBF versus MTTF. It all boils down to one simple question. Can you fix it, or do you have to replace it? Mean time between failures, that's for things you can repair, like a server. Mean time to failure is for components you just toss when they break, like a hard drive. It's all about repair versus replace. All right, this next idea, this is a total game changer. It's a huge shift in how you think about failure. What if, instead of fearing failure, you actually budgeted for it? Like it was a resource you could spend? And that's exactly what an error budget is. It totally reframes the conversation. And look, this is not an excuse to be sloppy, far from it. It's a strategic resource. It's the permission you give your team to innovate, to roll out new features, and to take smart risks, all without jeopardizing your core reliability. And you know what? The math behind it is super simple. You just take 100%, subtract your SLO, and boom, that's your error budget. So if your goal is 99.95% uptime, that little 0.05% is your budget. For a month, that gives you about 22 minutes of acceptable downtime to spend. So what does this look like in practice? Well, it gives you a really clear, data-driven way to make decisions. If you look at your dashboard and you've got plenty of budget left in the tank, great, ship that new feature. But if that budget is spent, whoa, hold on. The priority immediately flips. It's all hands on deck for reliability before your customers start to feel the pain. Okay, so we've covered setting targets, measuring them, and even budgeting for failure. But what if we could get ahead of the problems? How do we go from just managing failure to actually preventing it before it even happens? Well, this is where a classic engineering technique comes into play. It's called failure mode and effects analysis, or FMEA. It's basically a super structured way of playing what if for your entire system. You're systematically asking, what are all the ways this could break? And this is what it looks like in action. You use a worksheet, kind of like this one, to get really methodical about it. For every single component, you think about how it could fail, what would happen if it did, and, this is the most important part, what you're going to do now to stop it from happening. It turns vague worries into an actionable to-do list. So, after all these acronyms, all these charts, what does it all add up to? It's about something way bigger than just hitting numbers. It's about building a completely different kind of culture, a culture of reliability.
Ultimately, this whole playbook is about creating a culture where everyone owns reliability. You end up with a shared language, so product teams, engineers, and ops are all on the same page. Decisions get made with data, not just gut feelings or, drama. And that's the key. Reliability becomes everyone's job.
So, here's the crazy part. By leaning into failure, by measuring it, planning for it, even budgeting for it, you actually end up building stronger, more innovative systems. It frees you up to move faster. So let me leave you with this question. What could you build if you weren't so afraid of failure? Thanks for watching.